Question 3. Let f be a function that is twice differentiable for all real numbers. The table above gives values of f for selected points in the closed interval 2 to 13. So the first question is estimate f prime of 4. Show your work. So we want to find the slope at the point 4. So slope of f of x at x equals 4. That's what this is asking for. So we don't have information about 4, and we don't have a function we could differentiate. So what we're going to do is look at the secant line. I'm going to find the slope of the secant line close to 4. So I'm going to find the slope of the secant line between 3, 4 and 5, negative 2. Notice it says estimate, so we're not finding an exact value. So our slope is going to be 4 plus 2, 3 minus 5, which gives me 6 over negative 2, negative 3. So f prime of 4 is going to be approximately negative 3. Part B, evaluate the definite integral from 2 to 13 of 3 minus 5 f prime of x dx. We want to show our work. So the first thing I'm going to do is I'm just going to integrate this. So we're doing 2 to 13, 3 minus 5 f prime of x dx. So I'm integrating this with respect to x. So this will become 3x minus 5 f of x. And we're going to evaluate this from 2 to 13. So that gives me, when I plug 13 in, I get 39 minus 5 f of 13 minus 6 minus 5 f of 2. So now I'm going to go up to my chart. 39 f of 13 we know is 6, so this is going to be 30, minus f of 2 is 1, so 5 there. And we get 9 minus 1, which is 8. Next question. Use a left Riemann sum with subintervals indicated by the data in the table to approximate the integral from 2 to 13 of f of x dx. Show the work that leads to your answer. So it might help again just to do a quick picture here. So here's what we got. We have a point, we need x values from 2 to 13. So let's say this is 12 right here. This would be 6, this would be 3, this would be 9. So 13 would be right about there. So we're at 2, 1, and we need to go from 1, and we need some negative numbers in there, to 6. So here's 6, 3, negative 3. So we have a point at 2, 1. We have a point at 3, 4. We have a point at 5, negative 2. We have a point at 8, 3. We have a point at 13, 6. All right, so I'm just doing this to help me visualize what it's asking for. The first interval we have here is, so I'm going to do 4 pieces. The first left Riemann sum is going to start at this 2 value, and it's going to create this little rectangle there. So that's going to give me an area of, these are rectangles, so it's going to be an area of 1 times 1 plus the next interval starts, it's going to start here and it's going to go down to there, kind of like that. It's actually this region here. It's not really going down at all because of that left endpoint, but it's going to have a width of 2 because we're going from 3 to 5, and it has a height of the left endpoint, which is 4. Our next one is going to be negative because of that left interval. So it's starting at 5 going to 8, so that's a width of 3, and it's going to have the left endpoint as the height, so negative 2. And our last interval grows by 5, and we're going to use our left endpoint, which is 3. It feels strange when you draw that picture. Maybe it's easier for you to do it without the picture. 1 plus 8 minus 6 plus 15. That's giving us 1618 as our approximation from 2 to 13 of f of x dx. Not the neatest there. Suppose f prime of 5 equals 3 and f double prime of x is less than 0 for all x in our closed interval from 5 to 8. Use the line tangent to the graph at x equals 5 to show that f of 7 is less than or equal to 4. Use the secant line for the graph of f on 5 to 8 to show that f of 7 is greater than or equal to 4/3. Okay, so this first piece, we know that f double prime of x is less than 0. So if f double prime of x is less than 0 for 5 to 8, then f of x is concave down on this interval 5 to 8. So let's just picture that. If we're talking, here's 5, here's 8. I don't know where it is, but I know it's concave down. So maybe it looks something like that, where it's concave down in that interval. Okay, so the first thing we need to do is we need to write, I'm looking at this second sentence, use a tangent line to the graph at x equals 5. So let's write that first. To write the equation of a tangent line, I need the slope of the tangent line and I need the point. Well, if our tangent line is at x equals 5, then the point would be the point 5, comma, -2 from my chart at the top. The slope is the derivative of f at 5, which we were given in the question is 3. And so my tangent line is, I'm going to use point slope, y plus 2 equals 3x minus 5. And the question asked you to find f of 7 and show that it's less than or equal to 4. So I'm going to plug in to find f of 7, plug x equals 7 into your tangent line. And I get y equals 3 times 2 minus 2, which is 4. So my approximation, my tangent line, says that f of 7 must be 4. Since this is a concave down situation, if I draw a tangent line here in my picture, the tangent line of a concave down question is always above the function. So because of the concavity and the fact that our tangent line says it equals 4, it's got to by default be less than 4. So therefore we know f of 7 has to be at least less than or equal 4. Based on the fact that it's equal to 4 from my tangent line, and my tangent line is an overestimation. Okay, the second piece, change colors here for the second piece in red. Second piece says find the secant line. So we want to use the secant line on 5 to 8. So I'm going to use the point 5, -2, and 8, what was 8? 3. I'm going to use this, write my secant line. So my slope is 5 over 3. And my equation, I'm just going to use one of these 2 points. It makes no difference which one. So maybe I'll do y plus 2 equals 5/3 x minus 5. So I used the first point. And it asks us to find f of 7. So I want to plug in f of 7. So plug in x equals 7, we get y equals 5/3 times 2 minus 2, and that's 10/3 minus 6/3, y equals 4/3. That was hard for some reason. So we got now from our secant line that our secant line must be giving us a 7 value of 4/3. Now the secant line, because of concavity, is always an underestimation of a concave down. And so f of 7 must be at its smallest 4/3 or larger.